In this video, we're going to look at how we can use the SQLmap tool to exploit SQL injections. SQLmap is a powerful open source tool that aims to automate the activity of performing SQL injection attacks. SQL injection is a very common vulnerability within web pages and APIs, so it's very useful during a penetration test to have an automated way of looking for these SQL injection vulnerabilities. To get started, we first need to download and install the SQLmap tool. To do that, open up a web browser and navigate to the URL seen at the top of my screen, which is sqlmap.org. On the main screen, because we're working on a Windows system, we're going to click on the download.zip file. But there are distributions available for Linux as well, and you would click on download.tar.gz. Alternatively, you could also clone this directly from the repository. Once you've downloaded the zip folder, extract it to a directory of your choice, and then open up a PowerShell window or a terminal within that directory. And then, once you have your PowerShell window open within that directory, you could run the ls command to see what's available inside that folder. In this case, we're interested in the SQLmap.py file, which is the SQLmap tool. We also need to make sure that we have Python installed on our system in order to be able to run this tool. We can run the tool by typing in python sqlmap.py. And it tells us that we are missing a mandatory option, and it gives us a usage example. Pressing enter to continue, I can retype that command and pass -h for basic help or -hh for advanced help. When I pass -h, I see a detailed output of all the different ways that I can use the SQLmap command. So this can be a very useful reference when you're learning and getting used to the tool. So let's go ahead and start building an SQLmap command. We have a vulnerable web application running on localhost at port 5000, and it has a /login endpoint that is vulnerable to SQL injection. So that's what we're going to be using to test with SQLmap. So I'm going to start with the command python sqlmap.py, and then I'm going to pass it the -u flag. And if we scroll up, we can see the -u flag is used to pass the target URL. So in this case, it's going to be the location of my API endpoint, which is http://127.0.0.1:5000/login. Next, we're going to pass the --data equals flag. And if I scroll up under the request header in the help output, I can see the description for this is the data string to be sent through a post request. So I'm going to pass it username equals admin and password equals test. Then I'm going to pass it the -p flag. And if I scroll up into the injection section of the help, I can see the -p flag is followed by a test parameter, and this is where I can pass the testable parameters. And the testable parameter that I want to test is username. And then I'm going to pass it --dbs. Once again, if I scroll up, I can see under the enumeration section, --dbs enumerates DBMS databases. And then I'm going to hit enter. And now the tool is running. And we can see that it was not successful. And this is because we have a critical warning saying that we're not authorized. Try to provide right HTTP authentication type and valid credentials. So in this case, we haven't passed valid credentials to the API, and that's what it's found. So SQLmap hasn't been able to do what it needs to do. If I return to the command, and instead of test, I put in password, which is the correct password for the admin account, and I hit enter, we should see a different output. Now, we do see a different output, and we can see what SQLmap has done. First, it tested the connection to the target URL. Then it checked if the target is protected by WAF or IPS. Next, it tested if the target URL content is stable. It found that the target URL content is stable. And then we see the most interesting one, which is heuristic basic test shows that post parameter username might be injectable. And it found that we're possibly working with an SQLite database. Next, it started testing for SQL injection on the post parameter username. And it tells me that it looks like the backend DBMS is SQLite. Do I want to skip test payloads specific for other DBMSs? And skipping these test payloads will make things go much faster, so I'm going to type in Y and hit enter. Next, it asks me for the remaining tests, do I want to include all tests for SQLite extending provided level 1 and risk 1 values? So I'm going to type in Y again and hit enter. And once again, we see a critical warning, warning us again that we're not authorized. Below that, we can see that SQLmap hit a 500 internal server error 4 times and a 401 authorized error 1 time. However, we now know that the username and password combination is correct. So we can actually tell SQMap to ignore that code by going back to our previous command and adding in a flag --ignore -code equals 401. And then hitting enter. Now that we've ignored the 401 code, we see a lot more output because it's getting past that error. And at the bottom of the output, I see a prompt saying post parameter username is vulnerable. Do I want to keep testing the others, if any? At this point, I found a vulnerable injection point, so I'm going to type in N for no. And now SQLmap has gone ahead and enumerated the database for me. So below that prompt, I see SQLmap identified the following injection points with a total of 46 HTTPS requests. And then it gives me the output of parameter, username, the HTTP method was post, I have some type information, the title is an AND Boolean-based blind where or having clause, and then I have the payload that was actually successful for doing the SQL injection. And we can see it used username equals admin, apostrophe, and 7267 equals 7267, which is a truthy statement, meaning that this will always evaluate to true, and fvpj equals fpbj and password equals password. Below that, there was another payload that it sent, which also demonstrated the SQL injection, and then we have a third payload which also worked for SQL injection. It confirmed the backend DBMS is SQLite, and then we have a warning on SQLite it's not possible to enumerate databases. And then it gives us the output for any HTTP error codes that were detected during the run, and any data logged was logged to a text file for this run. So this is how we can use the SQLmap tool to automatically uncover SQL injection vulnerabilities in an API or a web page, which can be extremely useful during a penetration test.